Yo, what's up everyone? Welcome to Descriptive / Laboratory Chemistry Part 7. Today we're going to be talking about the color of solutions. So if you have a solution with a solute that contains a transition metal, your solution may be colored. And this diagram does a good job of kind of summarizing all the possibilities that you have. So, a solution which has a solute containing titanium 3+ is going to be purple colored. So titanium 3+ would be purple colored. If you have copper, that would be kind of bluish. Nickel is greenish. And depending on the charge of the compound that you have, so something like vanadium 2+, vanadium 3+, 4+, 5+, are all going to have different colors. For any other transition metal that isn't on this diagram, it's safe to assume that the solution is going to be colorless. So let's do a bit of practice with this. So which salt dissolves in water to give a pink solution? Okay, so let's go through all these answer choices. First A, we have cobalt acetate. Cobalt acetate means that we're dealing with cobalt 2+, which is this one right here. And cobalt 2+ is going to produce a pink solution. So A can stay as a possible answer. Let's look at B. So copper sulfate. Copper sulfate means you're dealing with copper 2+. And copper 2+ right here is kind of bluish, so that's not pink. C, we have iron nitrate. Since there's a subscript of 3 on the nitrate here, we know that we're dealing with iron 3+. And iron 3+, if you look, has a yellowish color, and that's not pink, so it can't be C. And then D, we have zinc chloride. If you look, zinc isn't even on this chart, so it's safe to assume that zinc is going to be colorless. So the only answer choice that really makes sense here is going to be cobalt acetate, so answer choice A. Let's go on to another problem. Which compound will form the most intensely colored 0.01 molar aqueous solution? Okay, so let's go through all the answer choices. First of all, we have KMnO4. The transition metal that we're dealing with here is going to be the manganese. But the manganese could have different colors based on the charge of it. So what's going to be the charge of manganese in this compound here? Well, K, potassium, has a charge of +1, and oxygen has a charge of -2. So if you have one potassium, so +1, +4 oxygen, so 4 times -2, that means your charge is going to be -7. So the manganese needs to have a charge of +7 to make this compound be neutral. So that means we're dealing with manganese 7+, sorry, that should be Mn. And so we're going to be dealing with this brightly pink solution. So this could be a potential answer since the pink is so brightly colored. Let's look through the other ones. So we have KClO4. You don't have a transition metal here, so that's not going to be colored, so we can cross out B. C, we have KAlSO4 too. Aluminum is a transition metal, but it's not on this chart, so it's safe to assume that it's not colored. And then you have potassium iodide. Iodine is not a transition metal, so the only answer that you're left with here is going to be A, which is the answer. Let's do one more. So which cation forms a colorless aqueous solution? This one's probably the easiest out of all of them, but let's go through it anyways. So A, we have cobalt 2+. Cobalt 2+ is right here. It's kind of pinkish, so that has a color. Nickel 2+, that's green, so that can't be it. Copper 2+, that's kind of blue, so that can't be it. And then you have zinc 2+. Zinc 2+ isn't on this chart, so it's safe to assume that you have a colorless aqueous solution. So the answer here is D. So why do some of these transition metal ions create a colored solution? Well, if you look at a random solution here, the answer is D. If you look at some solution here, some mystery solution, what's going to happen is that when I shine light through it, when I shine white light is light that contains all other wavelengths of light. Depending on the properties of the solute, so depending on whatever I have dissolved in this solution, some of those wavelengths are going to get absorbed. So let's say I shine this white light through this solution and only green and blue come back. What that means is that the solution absorbed the red light, the orange light, the yellow light, the violet light, and the indigo light. So what's the color of the solution? Well, if green light and blue light are the only ones that are allowed to pass, you're going to have a mix of green and blue. So you're going to see like a cyan colored solution. So what that means for our transition metal cations is that when you have a solution of them, they're allowed to absorb certain wavelengths, but allow other wavelengths to pass through. And the wavelengths that pass through are what determine the color of the solution itself. So if you look at something like nickel, this is the absorption spectrum of nickel. What it tells you is that if you have wavelengths around 400 to like 450, that's going to get absorbed a lot. If you have something like 600 to 800, that's also going to get absorbed a lot. And so what I mean by these numbers is that we're talking about wavelength on the visible spectrum. So you can see 400 to 450 is like this purplish region, and then 600 to 800 is this yellow reddish region. So the only regions that are not absorbed is going to be this green bluish region. Now that reflects really well with what we've seen, because if you look at actual nickel, you realize that nickel is this light greenish color. And this light green color comes from the fact that blue light and green light are allowed to pass through. So the reason that these transition metal ion solutions have certain colors is because the colors that you see are the ones that don't get absorbed. Every other color, the properties of the metal ion allows them to absorb those wavelengths of light. And that's it for colors of solution. If you want a more detailed explanation for why transition metal ions have these certain properties, there's a theory called crystal field theory, which I'll have a video on this coming up after this, that kind of explains why this happens. It also explains magnetism. So if you would like to learn more about that, then watch my next video on that. But other than that, that's all I have. I hope you were able to learn something, and I hope to see you later. Thank you.